Dear students, in this class we will explain how to construct a confidence interval for population proportions for large samples. How to construct confidence interval for population proportion if the sample size is sufficiently large. Large means NP and N into 1 minus P greater than 5. The procedure that we discuss is known as one sample Z interval procedure for a population proportion. One sample Z interval procedure for a population proportion, or simply Z interval procedure for a population proportion. And it is based on the sampling distribution of the sample proportion we have discussed in the previous class. And the procedure is similar to one sample Z interval procedure for one sample Z interval procedure for a population mean. Here it is population proportion. That is the only difference. Now, a condition for constructing confidence intervals for a population proportion is that the number of success x, the number of success x, and the number of failure n minus x are both greater than 5. X and n minus x greater than 5. That is the condition for constructing confidence interval for a population proportion. This condition can also be stated as n into p hat and also n into 1 minus p hat greater than 5. This condition can also be stated as n into p hat and n into 1 minus p hat both 5 or greater than 5, which for an unknown p corresponds to the rule of thumb for using normal approximation. So this is the condition for constructing confidence interval using Z for a population proportion. And the procedure is based on two assumptions: simple random sample, number of success x, and also number of failure n minus x, both 5 or greater, that we have discussed. Then let us see what are the steps for constructing confidence interval for population proportion using the Z statistics. Now, determine alpha, the significance level. Then, once we determine the level of significance, then find Z alpha by 2, because for confidence interval construction we use Z alpha by 2. The next step is the confidence interval for P is P hat plus or minus Z alpha by 2 into root of P into 1 minus P. Instead of P, we have P hat into 1 minus P hat by N. P hat plus or minus Z alpha by 2 into root of P hat into 1 minus P hat by N, where N is the sample size, P hat is nothing but x by n. x by n, number of successes in total number n, that we have discussed earlier. And the next step is interpret the confidence interval. It is similar in appearance to constructing a confidence interval for population mean using S bar plus or minus Z alpha by 2 sigma by total. Instead of x bar, we have the estimator p hat, Z alpha by 2, the critical Z values. If alpha is 5%, then it becomes 1.96. Then this is the standard deviation of p hat. P hat is x by n. Then we interpret the confidence interval. Now let me consider an example. In the example of US employees playing hockey, 1010 US employees were sampled, and suppose that 202 said yes. Construct a 95% confidence interval for the population proportion P. That is, construct a 95% confidence interval for all the employees who play hockey. Now, n is 1010, n is 1010, x is 202, n minus x is 808. For alpha is equal to 0.05, Z alpha by 2 is equal to 1.96. These are quantities familiar to us. Then for confidence interval is p hat plus or minus Z alpha by 2 root of p hat into 1 minus p hat by n. And we know that both x and n minus x are greater than 5. A condition required for constructing confidence interval satisfied. Then what is p hat? P hat is equal to x by n is equal to 202 by 802 is equal to 0.2. So the 95% confidence interval is 0.2 plus or minus 1.96 root 0.2 into 1 minus 0.2 by 1010. The solution will give you 0.175 to 0.225. This is the 95% confidence interval. This is the 95% confidence interval for the proportion of US or Indian employees who play hockey at least once in a year. So we will say that we are 95% confident that the percentage of all US employees who play hockey at least once in a year is 17.5% to 22.5%. In our example, it is 20%. 20%, but the range is 17.5% to 22.5%. This is how we construct confidence interval for one population proportion. And assuming that sample size is, these two conditions are satisfied, n and so x and n minus x greater than 5, or p into n into p, n into 1 minus p greater than 5. That is the 95%. You can construct a confidence interval fixing alpha at 5%, 1%, 10%. That is your choice.